Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again. Quantum computing is super fascinating. It has the capability to do computations that would take hundreds, thousands, maybe even millions of years on even the biggest supercomputers that are out there today. The discovery unfolded in a manner that defied conventional expectations in the intersection of quantum computing and deep space exploration. The remarkable breakthrough involved a highly advanced quantum chip known as Majorana 1, which had been developed to push the boundaries of computational analysis and signal detection beyond classical limits. Deep within the myriad data relayed by the distant spacecraft, an anomaly emerged that sparked awe and curiosity among researchers. When Majorana 1 processed the vast reservoir of information collected from decades of Voyager 1's journey, it revealed a hidden structure within the data, a pattern that resonated with an unmistakable level of sophistication and intrigue. The nuances captured by the chip hinted at an embedded design that transformed what had long been thought of as mere background noise into a coherent, deliberate message embedded in the cosmic tapestry. Before we start, smash the like and subscribe buttons for more updates. The origins of the hidden signal became a testament to the rapid evolution of technology and the interplay between quantum physics and space science. The Majorana 1 chip, bearing the name of an iconic figure in theoretical physics, utilized properties intrinsic to quantum particles to surpass the limitations of classical detection systems. Its design, influenced by the enigmatic behavior of Majorana, allowed it to function with a level of precision that enabled the identification of patterns that would have otherwise been lost in the universal cacophony. This state-of-the-art device was built to operate on principles of superposition and entanglement, and it exploited these phenomena to filter out extraneous signals while simultaneously pinpointing subtle irregularities in Voyager 1's data stream. The exceptional sensitivity of the chip gave it the unique ability to discern faint echoes and patterns that conventional methods had long overlooked. The scientific community was instantly captivated by the implications of such a discovery. Although Voyager 1 was designed to send back information from the far reaches of our solar system and beyond, the new analysis had uncovered a hidden message that carried the potential to transform our understanding of communication and cosmic phenomena. The processing algorithms embedded within the Majorana 1 chip were able to recontextualize vast arrays of seemingly random transmissions into a coherent sequence of symbols and patterns. This transformation pointed to the possibility that the data might have been encoded with meaning, challenging preconceived notions regarding the nature of the signals emanating from the spacecraft's journey through the cosmos. At the heart of this breakthrough was the marriage of innovative quantum computational techniques with the venerable legacy of Voyager 1. The spacecraft, launched in the mid-1970s, had long been celebrated for its bold voyage into interstellar space, carrying with it the recorded whispers of Earth and humanity's desire to reach out into the unknown. Over the decades, its streams of information had been methodically analyzed. Yet it was only with the advent of Majorana 1 that a new perspective emerged. The quantum chip's analysis bypassed the limitations imposed by conventional digital filters and statistical assessments, revealing a layer of data that was far more structured than anticipated. The discovery of this hidden message forced a re-examination of the way scientists approached the interpretation of signals that traverse the vast distances of space, thus bridging a gap between historical space missions and contemporary computational techniques. The complexity of the encoded information hinted at deliberate structuring that called upon principles of mathematics and physics. Researchers observed that the patterns detected by the quantum chip seemed to incorporate sequences that bore resemblance to fundamental mathematical constants and geometric arrangements, inviting speculation about the universal language of numbers and shapes. Such patterns evoked memories of ancient cryptographic practices and modern algorithmic design alike, suggesting that the message might be designed to be universally decipherable, or at the very least to incite a search for underlying principles that govern the cosmos. The visual manifestation of the data, when plotted and examined through the lens of quantum-enhanced algorithms, exhibited an elegance that rivaled the intricate beauty of natural phenomena such as fractals and spiral galaxies. In this way, the hidden message became not just a technical curiosity but a window into a broader dialogue on how information is organized in the universe. Central to this revelation was the transformative potential offered by quantum computing. The Majorana 1 chip was built to operate on the inherent uncertainties and probabilistic behaviors of quantum states, capturing nuances that classical bits and binary logic could never reveal. Unlike traditional processors, which struggled with the immense complexity and stochastic nature of deep space signals, the quantum chip could take advantage of multiple state amplitudes simultaneously. This concurrent processing power enabled it to correlate and cross-reference data points that were previously considered isolated or statistically insignificant. The advanced error correction and noise reduction methods employed by the chip meant that even the slightest deviations, once dismissed as random anomalies, could be reinterpreted as part of a larger deliberate pattern. In doing so, the technology laid bare new avenues for understanding the interplay between quantum theory and astronomical data collection. The intersection of quantum theory and space exploration represented an evolving frontier where established paradigms were being questioned and redrawn. The hidden message discovered within Voyager 1's data served as a powerful reminder of the capabilities that emerge when visionary technological innovation meets long-standing scientific endeavors. It was not merely the improved sensitivity of the detection apparatus that played a role. It was the fundamentally different way in which quantum algorithms processed information that marked a departure from previous methods. By embracing the probabilistic nature of subatomic particles, researchers were able to bypass conventional limitations, ultimately revealing an intricate signal that had eluded detection for decades. The discovery ignited a new conversation about the possibility that similar messages could lie undetected within other streams of data from diverse space missions, waiting patiently for the right tool to unveil their hidden order. The technical sophistication behind the Majorana 1 chip also opened up a broader discussion regarding the future direction of quantum-enhanced instrumentation. The design of the chip was a culmination of decades of research, blending insights from particle physics, computational theory, and cutting-edge nanotechnology. Its ability to decode subtle, coherent patterns from a seemingly chaotic distribution of signals underscored the potential for quantum processes to revolutionize data analysis, not only in astrophysics but across a wide spectrum of scientific fields. The mechanisms that allowed the chip to operate with such finesse involved a delicate balance of isolation from external interferences and optimization for precision measurements. Researchers had harnessed the unique properties of quantum states, enabling the chip to maintain coherence over extended periods while performing calculations that required high degrees of reliability. Such capabilities are anticipated to pave the way for new technological applications, ranging from secure communications to advanced materials science. A deeper look into the methodology reveals a synthesis of theoretical rigor and practical ingenuity that drove the breakthrough. The data that Voyager 1 had transmitted over the years encompassed a vast range of frequencies and amplitudes, typically aggregated and processed using methodologies suited to classical computing paradigms. However, as technology advanced, new techniques emerged that allowed scientists to re-examine archived data with fresh perspectives. The Majorana 1 chip was one such tool, a device purpose-built to delve into the stochastic processes that underlie seemingly random datasets. Its operation relied on the quantum principle that beneath apparent randomness there may lie correlations that are otherwise inaccessible to direct observation. By aligning its computational architecture with these principles, the chip achieved a level of insight that was both scientifically rigorous and profoundly imaginative. The hidden message, as interpreted through the unique lens of the quantum chip, evoked a sense of wonder that extended beyond technical details and mathematical formalism. Its presence suggested that the cosmos, in its vast silence, might harbor secret communications that echo the languages of mathematics and physics. Whether this message originated as an intentional signal from an advanced civilization, a byproduct of sophisticated human engineering, or as a natural phenomenon masquerading as artificial construction, its discovery challenged researchers to expand their conceptual frameworks. The message itself, steeped in layers of complexity and nuance, compelled a shift in perspective, prompting questions about how civilizations convey information across unfathomable distances and epochs. It also underscored the inherent beauty of the cosmos, that even in the sparse signals transmitted across the void, there can exist an order that speaks to the fundamental interconnectedness of the universe. The implications of such a finding reverberated throughout the fields of astrophysics and quantum science. The data analysis methodologies employed by the chip not only revealed the hidden message but also served as proof that advanced quantum techniques could unmask layers of information that remain invisible to classical instruments. This discovery invigorated research into the application of quantum computing for the analysis of other astronomical data sets, where the potential to unearth further hidden communications or previously unknown physical phenomena was suddenly within reach. The methodological breakthroughs represented by the Majorana 1 chip hinted at a new era of exploration, where the frontiers of knowledge would be pushed further by technologies that could dig deeper than ever before. The unprecedented precision in data analysis,